In this video, we're going to look at horizontal shifts of simple hyperbolas. This is our general form y equal to k over x minus p plus q. In this case, we're going to take p unequal to 0, but we're going to make q 0. So the q there disappears. So first of all, look at our green graph. A green graph, I've just made it here, drawn it here, the mother graph, the standard one that you have to know even if I wake you up at 3 o'clock in the morning. Then you must know this is the standard graph. It has axis of symmetry y equal to x and y equal to minus x, and it has vertices at a1, 1 and b minus 1, minus 1. A reminder of the properties of a simple hyperbola, the mother graph y equal to 1 over x, which has a domain r without 0 and a range r without 0, vertical asymptote, the y-axis, and horizontal asymptote y equal to 0, the x-axis. We have the lines of symmetry y equal to x and y equal to minus x. This you must memorize. If we look now at the red graph, we will look at this sketch just now again, but the algebra here, I can only compute y equal to 1 over x minus 1 when the denominator is unequal to 0. So x may not be 1. So that means in the domain I may not have 1. So I exclude the number 1, which will cause the denominator to become 0. I exclude that from the domain. But for the range, since the numerator cannot be 0, I must exclude the 0 from the range. So I cannot have answers, doesn't matter what x value I use, I can never have an answer of 0 for y equal to 1 over x minus 1. So it's only the numerator that can give us 0 values. So in this case, our vertical asymptote is now x equal to 1. And our horizontal asymptote is still y equal to 0. The lines of symmetry is exactly this x minus 1, which was in the denominator, that x minus 1, because the x changed to x minus 1. So this is the 1 and the other one is minus x minus 1. So that will give me minus x plus 1. So what happens is, so the red graph is the green graph shifted exactly 1 unit to the right, That is what happens because of this x minus 1. Remember, we have k over x minus p. And this minus p, that p causes the horizontal shifts. So it's 1 unit because in this case p is equal to 1. So let's look at the graph. This is now y equal to 1 over x, and this is my graph 1 x minus 1. If I look at x equal to 2 and I plug it in there, 1 over 2 minus 1, then I will get 1 over 1, which is equal to 1, which was the value there. So that value shifted 1 unit to the right. If I plug in, if x is equal to 0, then 1 over x minus 1 is equal to 1 over minus 1, which is minus 1. So that is why that value becomes this value there. So everything just moved 1 unit to the right, and it comes from the p value there. That p value is plus 1, which is positive. That's why it's moving to the right. So we conclude if k is positive and p is positive, then the hyperbola shifts horizontally p units to the right. The vertical asymptote shifts as well as the axis of symmetry shift with the graph. Let us see just look back at the axis of symmetry. So you see here, the small dots here, that is the line y equal. We can see that this line y equal to x has shifted 1 unit to the right to get this line y equal to x minus 1. This line y equal to x minus 1 because it cuts the y-axis at minus 1. If we look at the other line y equal to minus x, then if I take a point there, then I can also see it moved 1 unit to the right.